Section 5.5, Calculus 30, page 233 in the textbook that we're using. The red Stewart one. We're going to talk about a process for curve sketching. As I mentioned before, there will be no graphing calculators allowed here now. Because what you need to do is you need to use the calculus methods that we've just talked about over this last chapter and a half. And you're going to be using those methods to sketch a graph. Now, a curve sketching, any kind of curve, whether it's anything that looks like this, or something a little more, or even a straight line. I mean, a straight line, technically, we call that a curve too, although you might not think it's a curve. So it's any function, okay? Now, there are certain headings, and the headings we're going to talk about are headings A through H. So I'm going to talk about aspects of a curve that we can determine. Some of them are directly calculus related, some of them are not calculus related. For example, the first thing you want to identify is the domain. So A is domain. We're talking about a process. The first step is identifying the domain. Now, in some kind of function, what we're looking for, and of course the domain is x values, right? So we're looking for x values that are restricted. So you want to note restrictions, okay? And those restrictions would include, but not limited to, the square root of anything that would be negative. That's bad. Any x values that give you a negative underneath the square root sign, bad. If we have a denominator of 0, those x values that cause that 0 in the denominator are restricted, okay? So you may have, if it's a polynomial function, continuous function, you may have the domain is, x, e, r, which means that we have we have the domain is an element, all the values of x is an element of all real numbers. So anything is possible. You may have, negative infinity. So you may have domain equals negative infinity to 3, and then also 3 to positive infinity. That's the technical way of expressing that x cannot equal 3. Am I okay with you saying the domain is all real numbers except x can equal 3? Yeah, I'm okay with that. And just as long as you understand that and able to communicate that, this is fine. Okay, so A is domain. Now, as far as the restriction goes, what might that indicate? So if we're talking about sketching a graph, what sort of characteristic of the graphs are we looking for when we're examining the domain like that? Not so much intercepts yet, no. But think about restricted values. Okay, y equals 1 over x plus 1. X cannot equal negative 1. What happens at negative 1? What happens here, this graph? It's either a gap or what? Yes, or a vertical asymptote. Now, which one happens here? You should know this. Yes, it's a vertical asymptote. Why? Because there is no other factor of x plus 1 on top. If it was x plus 1 over x plus 1, for some reason, then it would be a gap. So if this restriction that is in this factor here, if that can be divided out, it's a gap. If it can't be divided out, so 1 over x plus 1, then it's a vertical asymptote. Questions? All right, you might want to look at page 66 if you're wondering, if you want to look up that, the work we did on domain. That's the review and preview to chapter 2, looks like. Okay, so the next thing we want to pay attention to is intercepts. All right, intercepts. Now, we can gain a lot of wisdom and knowledge about a function if we know where it crosses the x-axis and where it crosses the y-axis, right? So if I know that I have an intercept here and here and here, if I know that I have those, that's great. If I know I have this as well, okay, that gives me a lot more information. The graph then could be something like this, right? But I know it passes here, 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 and here. So finding the intercepts right away, big deal. Couple that with letter A as well, if I know I have an asymptote somewhere, let's say I have an asymptote here, then you see how I'm piecing together what this graph might look like. It could look like this, and then like this, like that, or something. I don't know. Do you know what I mean? You can start to piece things together already. So how do we find intercepts? You remember? How do you find the x-intercept? Okay, let what? Let y equals 0. Yeah, solve for x. Very good. The y-intercept, you let x equals 0. Solve for y. So that's how you find it. Now, I mean, we'll do some examples, of course, but if you have like y equals x plus 1, okay, this is easy. If it's x plus 1 squared, you know, maybe it's not so much, right? But if you want to find the x-intercept, let y equals 0. So you have 0 equals x plus 1 squared. Okay, square root of both sides. You know, solve for x, right? X equals negative 1. Okay, so and so on. Find the y-intercept is easy. Just plug 0 in there. 0 plus 1 squared is 1. So that's pretty straightforward for the most part. But if you can identify your intercepts, and remember, no graphing calculator for this, so we're going to have to be able to do the algebra here. Okay, not really any calculus yet. Let's keep moving on. So domain and intercepts. The next one would be symmetry. And again, we're not into calculus yet. But we know that if a function is odd, there's some symmetry there, right? What's the symmetry that's associated with an odd function? And an odd function, if you recall, is this. F of negative x equals negative f of positive x, right? That's what an odd function looks like. And again, these are lessons that we've already been through, so I won't go over the details here. But what sort of symmetry does an odd function give us? Sorry? May I remember? Symmetric about what? The origin. Yes. It's symmetric about the origin. So you'd have something like, you know, this. What about even? What about an even function? Even. So that's f of negative x equals f of positive x. So if you interchange a positive or a negative of the same x value, they should be exactly the same. And what sort of symmetry comes from this? Symmetric about what? Remember? Yes, y-axis. So, you know, a parabola of some sort, right? Like this. It's even function. Okay, so again, we've got domain, we've got intercepts, and we've got symmetry. If you know there's some symmetry, you know where the intercepts are, you know where the asymptotes are, you're starting to piece together what this graph's going to look like. All right, so D, asymptotes. Again, not really overtly calculus stuff here yet, right? This is all sort of basic stuff. But asymptotes. So vertical, and we talked about those restrictions, right? So you want to refer to the restrictions on the x value and glean some information possibly there. Horizontal, right? The limit of the function as x approaches infinity. So you want to find if there's a limit there. If there is a limit, that's your horizontal asymptote. There's your vertical and horizontal. And you just quickly, and again, some of these headings, you know, you're not going to have to do much work. Like you think, oh, well, this is all I work already. But you know what? Maybe there's no restrictions, so there's no vertical asymptotes. Maybe, you know, the limit as f, as x approaches infinity is just infinity. Like it's some sort of polynomial function, so there's no horizontal asymptote. So you can You can notice that right away. You can kind of keep moving on through there. Okay, so that's 5.2. Yeah, the limits there. All right, E. Moving on. Intervals of increase or decrease. Okay, so where is the graph increasing or where is it decreasing? So here's where we start to get into the calculus, right? And you want to examine f prime of x, the first derivative. And of course, where it is greater than 0, right, positive, what does that tell us? Is that increasing or decreasing function when all the tangent slopes are like that? There's the points on the graph there that would yield that. So that would be increasing. And where the derivative then is negative or less than 0, then we would have this situation where they're all negative, and the points of tangency would line up something like this for these guys. And you see how it's decreasing, going down, right? Decreasing. You'll want, and this is sort of a review really of the chapter, this section, right? Really, because there's nothing new we're going to be learning here. We're just putting it all together. So this is basically a review. That's why I'm going through this so quickly. But we want to do sign analysis here, right? We kind of get this from sign analysis. So if you have your factors here, here, and here, and remember this, your f prime of x, you have your critical numbers listed here, and let's say it looks like this. Okay, for some reason. You know the function is increasing here, decreasing here, increasing here, increasing again there. So you can kind of put together sort of what's happening there, right? Questions? So we're putting all this together: domain, intercepts, symmetry, asymptotes, intervals of increase and decrease. That's what we got so far. Next one, and we're going to H. So E, F, G, H. So F. F is, this is now in the most recent stuff here that we've done. Find out where your local max and minimums are. And you have options there, right? Find your F prime, so the first derivative, and then you do sign analysis if you want. And you've already done sign analysis for increase and decrease, so really, you know, if you've already done that, then you can just look at that sign analysis. And if we go back up here, the sign analysis, hey, it's positive here, it's negative here, and it's 0 here, so that's a local what? Max. Negative, 0, positive, that's a local min. Positive, 0, positive, that's neither. Remember, where it changes, where the derivative changes sign, that's where we have a local max or min. The other thing you can do, if you didn't do sign analysis in E, then what you could do is find the first derivative, find the second derivative, right, and input critical numbers. Into the second derivative. Alright, so this is the second derivative test that we just got finished doing in the previous section, right? And I'll just make a note of that there. Second derivative test. You guys with me so far? Yes? Yeah? This is good? Okay. It's all ringing a bell, right? Okay. Very good. Okay, so G, almost done. We've got a lot of pieces in place here, but what are we missing? We're missing, the only things we haven't done is concavity here, really. Concavity. And so the second derivative, right, that was to test for max or mins. Concavity, we look for intervals, right? intervals for f double prime of x that are positive or negative. The intervals that are positive, what does that tell us about concavity? It's concave what? Anyone? Up. And negative? Yes, concave down. So that's going to be one of the final pieces, right? You've got 2 points here, and you've got an intercept here. You might be able to see, well, it looks like this should be concave down, but it could be, concave up here. How do I actually draw that? Well, then you know that this is part of, a concave up interval. And so, yeah, so if you're real careful about it, you would see that, and I didn't really draw this very well, I guess, but you would see that you would have to, this is a bit closer, say that's slightly concave up in this section, okay? Which is, of course, part of a bigger, piece like that's concave up. Right? So that's the final piece, and really H, I guess, there's really nothing to determine H, but H is just officially sketch the graph. Sketch the graph, including all of the pieces, all of the characteristics that you've uncovered about the graph. So you basically just put it all together, A through G, put it all together. All right? So that is the procedure for curve sketching. If you follow each of those, and of course I'll ask you to comment on each of these as we go through it, right? Like, what is the domain? Are there any restrictions? What are the intercepts? Solve for those, show me those. Is there any symmetry you should be checking? And again, you could just F, to the -1, or F of -1 and F of 1. Just check those right. That should be pretty easy for most, and you'll see if there's any symmetry at all. Asymptotes, where does it increase or decrease, local max or min, and concavity. So we'll put those all together, you get a pretty accurate sketch, okay? So that's the procedure for curve sketching, and where did I go there? And I'm going to, I'll do an example with you here next, okay? So that's the procedure, that's 5.5, procedure for curve sketching.